So what is this? This is ixlj6 factoring sums and differences of cubes. I would love to show you where these formulas come from, but I don't guess most of you will even watch the video. So no point in doing that. This particular guy is an a cubed minus a b cubed pattern. A cubed minus b cubed. It's something cubed minus something else cubed. Something cubed minus something else cubed always factors as a minus b times a squared plus ab. Aw, wrong button. Aw, hope I get the same problem again. So note to self. Dang it, it's different. Okay, so back through this. Still an a cubed minus b cubed pattern. Something cubed minus something else cubed. And it always factors as a minus b times a squared plus ab plus b squared. This is on your form quizzes, by the way. And it's coming pretty soon. So we have q cubed minus 1,000. Q cubed minus 1,000. I create a q cubed by taking a q and literally cubing it. I create 1,000 by taking a 10 and cubing it. So here's my letters here. This is A, and this is B. So going back to the original problem, all I gotta do is type in A minus 10, or sorry, Q minus 10. That's all it's gonna be. I wonder if I can do that right up here on the board. Did it recognize it? Q minus 10. Oh, nope, nope, go back. I have to actually type. It does not recognize it. So I'll type that in. Q minus 10. Fantastic. Find the quadratic polynomial that completes the factorization here. So let's write down our pattern again. Apparently I'm still on pen mode here. I'm using the a minus b pattern. The second set is a squared plus ab plus b squared. So to create s cubed, I have to cube in s. So the letter a is s. And to create a 216, b is 6. Because 6 times 6 times 6 is 216. 6 cubed is 216. Don't be that cute, it writes 18. 6 cubed is 216. So I can finish my pattern out now. I'm going to take the letter s and I'm going to square it. I'm going to add to that the product of s and 6, which is just 6s. And then I'm going to take that 6 and I'm going to square it and get 36. S squared plus 6s plus 36. Apparently I got it. This is s cubed plus 1. So the pattern here that I'm going to use is called a cubed plus b cubed. A cubed plus b cubed factors as a plus b, a squared minus ab plus b squared. And they want the first two terms. I mean, that's easy. To create an s cubed, you take an s and you cube it. So a is simply s. To create a 1, you take a 1 and you cube it. B is 1 because 1 cubed is 1. So this is just going to be s plus 1 and I'll be done with it. Awesome. All right, so here they try to trip you up by using variables. To create a c cubed, you take a c and you cube it. To create a d, you take a d and you cube it. All right, done with that one. Oh, they were kind of mean on this one. 36 point, we jumped up this. All right, so let's talk about this one. This is kind of like going back to the factoring by grouping one, where you pull out some stuff you can pull out. Both these pieces are divisible by 4, and you can also pull a q out. So there was some stuff done behind the scenes that you didn't see. A 4q was pulled out, and if you do that, you have q cubed plus 125r cubed. So there's where that 4q comes from. All right. This q plus 5r, well, if I think about my pattern that I just did, and I'll write that pattern out for you again. A plus b, a squared minus ab plus b squared. To create a q cubed, I use the letter q for a. A is q. To create 125r cubed, I take a 5 times 5 times 5 is 125. R times r times r is r cubed. So b is going to be 5r. So that's where that 4 plus 5, that q plus 5r comes from. Although I don't know that I need to teach you all this. They kind of already told you what a was, and I kind of already told you what b was. So let's think about what we're going to do here. We're going to take the a value of q and we're going to square it. Q squared. We're going to take 5r and q and we're going to multiply them together. So minus 5r q. And then we're going to take 5r and square it, positive 25r squared. And there's my answer. They actually have the q's before the r's, don't they? Okay. So let's type this in so you can have some faith that Mr. Milbrath knows what he's doing. I accidentally wrote the letter A. I actually don't use the letter Q's in class too much because they're really bad for me to write. Great job, Milbrath. So notice they pulled a V out. So I'm going to do that before I even go to the next step. V cubed plus 125. And it's the same pattern I used on the last example. A is V and B is 5. All that's missing on this one is V plus 5. Nothing more. Awesome sauce. I'm going to jump up a level. Level 5 of 7. I have no idea why they consider this a jump up a level. This got even easier. It's the minus pattern. Let me write that out for you again. A cubed minus b cubed factors as a minus b times a squared plus ab plus b squared. That's how she factors. So I have to take a 5 and cube it to get to 125. I have to take a t and cube it to get to t cubed. And for b, I take a 1 and I cube it. So 5t and 1. The reason they leveled up is because they want you to write the whole thing out. Okay, so I'm just going to plug into this. All right, everywhere I see an A, I'm a 5. T, and everywhere I see a B, I'm a 1. Just plug into that thing and be done with it. It's going to be 5t minus 1. I'm going to square 5t. That's going to be 25t squared. I'm going to find their product. 5t times 1 is plus 5t. And then when I square a 1, I get a 1. Oh, I hate the letter T's when you're writing stuff out. They look like plus symbols, don't they? The second piece, by the way, never, ever, ever factors. That was 5t minus 1, 25t to the second power, plus 5t, plus 1. There's actually more to this lesson. There's like the acronym SOAP and stuff to it, which I'll teach in class one day. 64v cubed plus 27, easy peasy. I take a 4 and a v and I cube it, I get 64v cubed. I take a 3 and I cube it, I get 27. All right. So thinking about my pattern here, this guy is going to be 4v plus 3. I'm going to square 4v and get 16v to the second. There's a minus sign here. Plus minus plus. 4 times 3 is 12. Don't forget about the v. And then I take the 3 and I square it and I get 9. Excelente. Oh, no, not real numbers here. They just threw in more variables. So this one's interesting. I noticed that both pieces have a d in common, so I pulled the d out. And when I do that, I have c cubed plus 64d cubed. All right, so the d goes up there, okay? I'm just going to take that d and I'm going to put it in right there immediately. I'm not going to work with them anymore, all right? So my attention is actually focusing on this. To create a c cubed, I take a c and I cube it. So a is c. To create a 64d cubed, I take a 4 times a 4 times a 4 and a d times a d times a d. So b is 4d. I'm going to write this all out and then I'll kind of throw it up in there and we'll simplify a little bit. So I have that leading d, then I have c plus 4d. One thing I haven't been doing on the other ones is showing some little nitty gritty. I take c and I square it, I get c squared minus, here I'm supposed to do 4d times c times 4d, and plus, I'm supposed to take a 4d and square it. That's what it looks like initially when you just plug stuff in. And I haven't been showing you that, I've just been kind of going through the computations and not showing you what happens. But anyways, we'll do that here. D times c plus 4d, c squared, it's just c squared, can't do anything with that. Minus c times 4d, which would probably be written 4cd, alphabetical order, just looks better. If you take a 4 and square it, you get a 16. You take a d and square it, you get a d to the second power. And the symbols I used were plus, minus, plus. That's correct for a sum of two cubes. And I know what I'm doing. All right, bump it up to the last level here. And I'll let y'all go. 2048 minus 108p. Ugh. Ugh. That's horrible. Wish it wasn't the end of the day here. But I got a hunch that 2048 is probably divisible by 108, but I could be wrong. I was wrong. Will that work in my favor? Close. I'm running through here and I'm trying to figure out some numbers here. So I'm close. Can't divide by that. Hold on a second. I don't know why people call me when I'm still at work. All right, so where were we? We were on this one. This one looked kind of interesting. So I think what I want to do on this one is I want to turn that number 108 into something that I can actually factor, like it's cubed, so maybe like a 64. 64 might work well. Maybe an 8. I'm going to divide these things by 2. I might have to do this in more than one step. I'm not sure. So these are getting kind of rough. Oh, still got that on. So here's what I'm thinking. I'm thinking pull a 2 and a P. And I might have to go back and pull some more. If I pull a 2 from 1048, I'm at 1024 P cubed minus 64. Now, there's something special about 1024. Can't think off the top of my head what it is. But give me a second and I will. Now, apparently I'm wrong. There's nothing special about 1024. So I actually want to pull some more out of this. It'd be nice if I can get down to 512. The problem is that 32 that's going to be floating around. That's the problem. I must just be having a moment here. I'm over here pushing buttons. I done forgot what I need to be doing here. So I need to get that to something cubed. Yep, I was having a moment. It sure was. What I should have done is I should have divided by no, this one is really bugging me. But it shouldn't be. All right, so here's what it is. Figured it out. Just took me a minute. How do I erase? What I should have done is I should have divided this thing not by 2, but by 4 from the get-go. So let me erase. I think this is the eraser. Yeah, that's the eraser. Sorry, my wife just called and she told me how much money she spent on some stuff we don't need. So that like really blew my train of thought. All right, let's pull a 4. Pull out a 4p. If you pull 4 from 2048, you're at 512. If you pull a 4 from 108, you're at 27. What I was doing off the side there is I was trying to think about numbers that I could take cubic roots of and see how to make this possible. All right. Now I know that 8p cubed is going to give me my 512p cubed. Can't really write a 3 that far up. I also know that a 3 cubed is 27. That's kind of what I was off to the side doing here, trying to figure out what's going to make this happen. All right, so the initial factorization, this is a difference of 2 cubes. I'm going to have 8p minus 3. Here I'm going to have to take that 8p and square it. I'm going to add to it the product of 8p and 3, so 3 times 8p, or 8p times 3, however you want to write it, nobody cares. And then finally I'm going to take my 8p, sorry, my 3, and I'm going to have to square it. That's what I'm going to be typing into this thing. All right, and I'll figure out what some of these pieces are as I do it. That one got pretty rough, didn't it? 4p times 8p minus 3. When I square 8p, I get 64p to the second. 3 times 8 is 24. And then 3 squared is 9. And I'm just looking to see if there's anything else. Every once in a while you'll run across a case where you can pull numbers out. And this is not one of them. So this should be my excellent, oh, the challenge zone. Let me do one of the challenge zone, then we'll call this a day. So we got p cubed q minus 512 q to the 4th. So it looks to me like you can pull a q from everything. You pull a q from p cubed q, you'll have p cubed left over. And if you pull a q from 512 q to the 4th, you'll have 512 q. I pulled, no, I hadn't done anything wrong. Thought I made a mistake real quick. 512 q cubed. So we have p cubed minus 512 q cubed. You cube a p to get a p cubed. You cube an 8 to get a 512. And you cube a q to get q cubed. I'm getting tongue-tied on these things. Here we square the p squared, plus, because it's a difference of 2 cubes, 8q times p is 8pq. And lastly, we square the 8q, and that's going to give us 64q squared. There we go. That one's a tongue tire, man. Twist your tongue. So I have a leading q, p minus 8q, p squared. I'll do one more of these. I wish they would use different letters other than P's and Q's. But they do what they do. And it is amazing what that does to a mind. It just throws me off for some reason. Just a little bit. It's enough to make me feel kind of a little slow. That's right, Milbrath. All right, one more and then I'll pause this thing and be done with it because I need to be going. V to the fourth minus 125 VW cubed. I can pull a V from both pieces. A lot of kids, when they do this, they don't ever write down their first step, and they never get it because of that. They just want to know what the final answer is. They don't even worry about the stuff in between. All right. The hard one for some of these kids is going to be that 125W cubed. This is the difference pattern, V minus 5W. Because 5W times 5W times 5W is 125W cubed. I square the V. I add the product of V and 5W, 5VW. And then I square 5W plus 25W squared. That'll be my final answer. This will be where I stop because I need to be rolling. Sorry about the interruption on the phone. I guess I could go back and edit that entire conversation out, but you know, whatever. I'm just looking for typos. I'd hate to miss this thing. And that's right. I could do one more and I'd get that badge, wouldn't I? But I don't feel like it. But who knows? Let's do this for you. I can pull out a 3 and an S. I believe I can pull out a 3S. If I pull a 3S from S to the fourth, I have S cubed. 162 divided by 3, 192 divided by 3 ought to be 64. Minus 64T cubed. That's really the big thing that I need. I need that first step. So I have my 3S, S minus 4T, because 4 times 4 times 4 is 64. T times T times T is T cubed. I'm going to square my S, S to the second power. I'm going to find the product of S and 4, so plus 4, sorry, the product of S and 4T plus 4ST. And then I'm going to square the 4t. 4 times 4 is 16. T times t is t to the second. And I'm just looking for typos. And I'm going with it. I got my badge. Spectacular. Spectacular. So if I got my badge, you can too, but you guys only have to take it to a 90, which is going to be pretty good.